Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about the quadratic formula. All right, so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It kind of goes, the song goes along to like Once Around the Mulberry Bush, that song, if you know it. So why do we use this? Some problems we cannot solve by factoring. They're not factorable, right? The quadratic formula works for every type of problem that's a quadratic, but it is a little bit more work than factoring. Usually factoring will be easier, but this will work for everything. It doesn't always give you the nicest numbers. Standard form of a quadratic is ax squared plus bx plus c. And so you want to put it in that form so that you can identify what number is A, what number is B, what number is C, and then you can plug it into the formula. Possible solutions, you could get one solution where you have only one answer, two solutions, or no solution. All right, so no solution is if you end up with a negative under the square root. All right, this one, x squared plus 10x minus 2 equals 0. So this is already in standard form. So I have A is 1. B is 10, and C is negative 2. So I like to kind of write those out. A is 1, B is 10, C is negative 2. And then I'm going to plug them into the formula, which is negative B plus or minus the square root of B squared minus 4AC all over 2A. So I'm going to plug it in. So it's negative 10, I plug in 10 for B, plus or minus the square root of 10 squared, again I plugged in 10 for B, minus 4 times A, which is 1, times C, which is negative 2, all over 2a, so 2 times 1. Now I'm just going to solve using like order of operations. So please excuse my dear Aunt Sally, parentheses, then exponents, multiplication or division from left to right, addition or subtraction from left to right. All right, so 10 squared becomes 100, 10 times 10. Negative 4 times 1 is negative 4. Negative 4 times negative 2 becomes positive 8. So I have 100 plus 8. And then inside of there, 100 plus 8 is 108. So I have negative 10 plus or minus the square root of 108 over 2. And in this problem, I went ahead and just did this in my calculator. So I did negative 10 plus 108 square root gives you a decimal. So you do 108 in your calculator, press the square root button, you get a decimal. I added negative 10 to that, and then I divided it by 2. Then I did it again, 108, hit the square root button, I got a decimal. I subtracted, so I did negative 10 minus that decimal, and then divided that by 2. And so I got 0.196 and negative 10.196. So those are my solutions. All right, so sometimes with the quadratic formula, your answers are not pretty numbers. All right, number 2, x squared minus 11 equals 4x. You can see that this one is not in standard form. So I need my x squared, then my x term, then my constant. So I'm going to move this 4x into the right after the x squared. If I want to move it to the other side of the equal sign, I'll have to subtract it. So I'm going to end up with x squared minus 4x minus 11 equals 0. So now I have a equals 1, because the number in front of the x squared is a 1. B is negative 4, and C is negative 11. So I'm going to do the quadratic formula. So negative b, so negative 4, plus or minus the square root of b squared, so negative 4 squared, minus 4, times a, which is 1, times c, which is negative 11, all over 2a, so 2 times 1. All right, negative 4 becomes positive 4. So I have 4 plus or minus the square root. Negative 4 times negative 4 is positive 16. Negative 4 times 1 is negative 4, times negative 11 is positive 44 over 2. 16 plus 44 becomes 60. Now, if I try to do 60 and do the square root of 60, I don't get a nice number, but I can simplify the square root of 60. So this is going back to our very first unit where we worked with radicals. And we could break that apart into the square root of 4 and the square root of 15. Remember that the square root of 4 is a perfect square, and it's going to end up becoming 2. So I have 2 square root of 15, and since 2 is on my bottom of my fraction, 2 will be good because I can cancel it out. So 4 divided by 2, I'm doing the first part in front of the plus, so I have 4 plus or minus 2 square root of 15. So the 4 divided by 2 becomes 2. And then the 2 square root of 15 over 2, the 2 and the 2 cancel, and it leaves me with just the square root of 15. So I would leave my answer just like this, 2 plus or minus the square root of 15. You could get what the square root of 15 is as a decimal and add it, like 2 plus that number and 2 minus that number. All right, number 3, x squared minus 8x equals 20. Again, this one is not in standard form. I need the 20 to move. It's a constant, so I want it to be at the end, but in front of the equal sign. So I move it to the other side by subtracting, and I get x squared minus 8x minus 20 equals 0. So A is 1, B is negative 8, and C is negative 20. All right, negative B plus or minus the square root of B squared minus 4AC all over 2A. So negative 8 plus or minus the square root B squared, negative 8 squared, minus 4 times A is 1 times C is negative 20 over 2 times A, which is 1. Negative 8 becomes positive 8 plus or minus the square root. Negative 8 times negative 8 is positive 64. Negative 4 times 1 is negative 4. Negative 4 times negative 20 is positive 80 over 2. 64 plus 80 becomes 144. So 144 is actually a perfect square, so this one works out pretty nice. The square root of 144 is 12, so I get 8 plus or minus 12 divided by 2. So I'm going to do 8 plus 12 and then divide by 2. 8 plus 12 is 20. 20 divided by 2 is 10. Then I'm going to do 8 minus 12 and divide by 2. 8 minus 12 is negative 4. Negative 4 divided by 2 is negative 2. So my answer is 10 and negative 2. I have 2 solutions. All right, x squared plus 6x plus 10 equals 0. This one is in standard form. A is 1, B is 6, C is 10. Negative b is negative 6 plus or minus the square root of b squared, which is 6 squared, minus 4 times a times c, all over 2a. All right, so 6 squared is going to become 36. Negative 4 times 1 is negative 4 times 10 is negative 40, all over 2. 36 minus 40 becomes negative 4. So this is where I run into a problem because I have a negative under my square root. If you try to do the square root of negative 4, you should get an error on your calculator because this is in the imaginary number system. And in Algebra 1, we don't work with negatives under the radical. So our answer would just be prime. All right. In Algebra 2, you would move on to solve that one. Number 5, 2x squared minus 8 equals 0. This one is in standard form. I just don't have an x term. So my x term must be 0. So A is B, or A is 2, B is 0, and C is negative 8. All right, so I have negative b, so negative 0 plus or minus the square root of b squared, so 0 squared, minus 4 times a, which is 2, times c, which is negative 8, all over 2a, so 2 times 2. Well, negative 0 is just 0, plus or minus the square root. 0 squared is 0. Negative 4 times 2 is negative 8. Negative 8 times negative 8 is positive 64. So I get 0 plus or minus the square root of 0 plus 64. 0 plus 64 is 64. I could have 0 plus that, 0 minus that. It's still going to be the square root of 64 over 4. Well, the square root of 64 is positive and negative 8. Remember that you always have a positive and negative when you take the square root, because 8 times 8 makes 64, and negative 8 times negative 8 also makes 64. So my answer, 8 divided by 4 is 2, so my answer is positive and negative 2. Number 6, 4x squared plus 9 equals 12x. I need to move the 12x over. That's going to give me 4x squared minus 12x plus 9 equals 0. So A is 4, B is negative 12, C is 9. I'm going to use the quadratic formula, so negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 12 becomes positive 12. Plus or minus negative 12 times negative 12 is positive 144. Negative 4 times 4 is negative 16 times 9 is negative 144 over 2 times 4 is 8. 144 minus 144 becomes 0. So I have 12 plus or minus the square root of 0. Well, the square root of 0 is just 0. So this is 12, just 12 divided by 8, which becomes 3 halves, which becomes 1.5. So in this one, there's only one solution. All right, go Seahawks.